Hey guys, welcome back to our notes. In example 1, part D, we need to simplify this rational expression and determine when it's undefined. So I need to see if there's a common factor of my numerator and denominator. So this quadratic function I can factor by looking for two numbers that multiply to make -2 and add to make 1. Those are 2 and -1. So my numerator factors to be x plus 2, x minus 1. For this second polynomial, I'm looking for two numbers that multiply to make -3 and add to make 2. Those numbers are 3 and -1. So this factors to be x plus 3, x minus 1. So first, I need to see when is this function undefined. It's when my denominator equals 0. So if x plus 3 cannot equal 0, x cannot equal -3. If x minus 1 cannot equal 0, x cannot equal 1. So now I can cancel out my greatest common factors, and I know it simplifies to be x plus 2, x plus 3, with these restrictions for when x is undefined. So E and F here are a little bit of special cases because when we put our polynomial in standard form, our leading coefficient is negative. For instance, E, if I'm trying to factor this, the best way to look at a polynomial before you factor it is in standard form. -x squared plus 2x over x squared minus x minus 2. So this binomial, the first thing I need to check for is a GCF. If the first term, when it's in standard form, is negative, factor out a negative GCF. I'm going to factor out a -2x, and that's going to leave x minus 1. Uh-oh. Not a -2x, just a -x, because 2 can't come out of that, so that's going to leave an x minus 2. Excuse me. So now on my denominator, I need to factor this trinomial, looking for two numbers that multiply to make -2 and add to make -1. Those are -2 and +1. So this factors to be x minus 2, x plus 1. So now that my denominator is factored, I can determine when it's undefined, my denominator cannot equal 0. So if x minus 2 cannot equal 0, x cannot equal 2. If x plus 1 cannot equal 0, x cannot equal -1. So now that I've figured out where it's undefined, I can cancel out my GCF, and I have -x over x plus 1 with these restrictions. So now for F, once again, it's already in standard form, but I see of this binomial, my GCF, my leading coefficient, is negative. So I'm going to factor out a negative GCF, -x, x minus 3. So now for this, I'm going to need to factor using X box. So for my x, a times c is 6 and -7. That's -6 and -1. So now I'm going to do my box. 2x squared, -6x, -1x, and 3. So now I need to pull out the GCF from my top row, which is 2x. 2x multiplied by x makes 2x squared. 2x multiplied by -3. And x multiplied by -1. So my denominator is 2x minus 1 multiplied by x minus 3. Now remember, our denominator cannot equal 0. So if 2x minus 1 cannot equal 0, x cannot equal 1/2. And if x minus 3 cannot equal 0, x cannot equal 3. So now I will cancel out my GCF of x minus 3, and it simplifies to be -x over 2x minus 1 with these restrictions on my x values.